In this video, we will be designing a system similar to YouTube. So let's begin. So first of all, you need to follow these steps in the interview. First of all, you need to get clarification on the requirements. So you need to define all the requirements and which requirements need to be implemented. And then you need to make some estimations of bandwidth and storage. Then after the design is clear and you have the estimates, you can go ahead with high level design of the system. And once the high level design is discussed, you can dive deeper into one or more of the specific components in the high level design. So let's start with defining the requirements. So first we will define the functional requirements. So if you are using YouTube, of course you would have used to view videos, search videos, but there is another class of users called creators who upload videos on the YouTube, and they also have certain requirements. So we will see the requirements from the perspective of both creators and viewers. So if there is a creator, then the client must be able to upload a video. Then the client should be able to upload certain metadata associated with the video, like title, description. It also has certain keywords, and then you can also upload custom thumbnail. YouTube also generates some thumbnail, but you can upload some custom thumbnail. Also, it should provide an option to delete a video. Further, it can provide a detailed analytics, like how many views a video is generating, and certain more analytics like how was the video watched, whether it came through some YouTube search, or it came through recommendation from certain other video, or it came through Google search or any other means. Or you can also see which geography in the world your viewers are from. So and at what time the viewership is highest. So these kind of analytics can further be added. Of course, it seems too much to handle in a tech system design interview within a time frame of maybe 30-40 minutes. So most likely we will not be discussing analytics, and most likely the interviewer will also not ask you to go into analytics detail. Then from the viewer's perspective, the user should be able to search for any video, search any title, and based on that YouTube will recommend show results, and it will show the most relevant videos. And then once the search is complete, you should be able to play the video, because that is the main purpose why you searched the video in the first place. Then you should also be able to like a video, like or dislike, or subscribe to a channel. You should also be able to comment on any of the videos. Further, if you see that when you are watching a video in the YouTube, there are certain videos in the side panel in the form of recommendation. If you are watching from a laptop, if you are watching in mobile, these side recommendations may not be there, but you can see in the bottom some recommendations are there. Also some recommendations come in the end of once the video completes. And here also we will not be discussing recommendation, because recommendation is a big subject in itself, and most likely your interviewer would also not ask you to dive into recommendation part. So these were the main functional requirements. Now let's see some of the non-functional requirements. One of the non-functional requirements is that the service should be highly available. So a service which is available let's say more than 99% of the time can be said as good. If it's less than that, it's not highly available, and this high availability is desired in this case. Also, it should be scalable. So as the number of users grow, it should be able to scale without impacting performance or any of the features. And then it should be reliable. That is, once you upload a video, it should not get lost in future. So that is the reliability part. And it should be consistent, but the consistent consistency is eventual. That is, it's not desired that it shows immediately. For example, it's okay if actually, let's say you uploaded a video and it's showing, let's say, 500 views. It's okay that the actual view was, let's say, 512, but it's showing 500 because after some time ultimately it will catch up with the real number. So even if it's not in real time, it's okay. And similarly for other features, like if the video has just been uploaded, or there are 100 likes and it's showing only 99 likes because it's not synced yet, then it's fine. So consistency is eventual in this case. And also the performance should be good. That is, for viewers, the streaming experience should be good. And there are many things that YouTube does along this. For example, depending on the speed of the connection, it can switch from a higher resolution to a lower resolution video. And also some other caching mechanism can be used in place so that it's able to fetch the video which is already popular very quickly to other users. Now let's start with capacity estimates. So let's estimate the storage and bandwidth requirements. So YouTube says that 500 hours of video is uploaded per minute. So even if you don't have this number in the interview, you can start with some number, like let's say there are 500 million daily active users for YouTube, and this will come for the bandwidth part. And let's say creators, let's say there are maybe 100 million creators, and they upload a video maybe on average once a week. Some creators upload daily, some creators may upload after a month or two. But on average, you can start with some estimate, like maybe every creator on average uploads one video per week, and the average video length is, let's say, 20 minutes. So it will be a long way. In this case, I am giving you a number that YouTube says that 500 hours of video is uploaded per minute. So if you calculate for per day, it should be 500 multiplied by per minute. So 60 minutes is 1 hour, and then 24. So this is 30k and then 24. So is equal to 720,000 hours of video per day. 720,000 hours of video per day. You can even calculate for month and years. Similarly, 1 billion hours of video is watched per day. So you can see that it's a read heavy service. So here read is much more compared to write. So write is just 720,000 hours per day, and the read is 1 billion hours of watch time per day. Now let's start with database design. So we will need a few tables. Of course, you will in real design you will need many more tables, but let's list down the main tables. So it's all about video. So there will be a video table with ID as the primary key, and then title of the video, and there is a description below each video. Each video also has a thumbnail, whether it's the default one or the user uploaded one. Then the channel in which it belongs to. So every channel will have certain owner, so that will be the user of that video. And then it will display information like how many likes it has, how many views it has, and tags which may not be visible, but it's associated with most of the videos. It's optional, but yeah, videos have tags associated with them, the keywords, which helps in searching the video. And then every video has a URL. There can be more fields, but these are the main. Then there will be a user table with user ID as the primary key, then username, email ID, and details of the users. Then all the videos also have comments, and comments can also have, this is a comment, and then within this comment there may be a reply, and this comment can also have likes. So there can be many more data associated with just the comment itself. So comment ID, and comment belongs to a certain video. So we also need to store the video ID in which the comment was made, the user who made the comment, and the comment text itself, the time the comment was posted, and other information like likes and more replies to it, and a few more things you can store. Then you can also have a channel table like channel ID. So every channel has a unique ID. Even same user can have multiple channels, but each channel should have a different ID. Channel name, user ID, the user who created the channel, the account in which the channel belongs, the number of subscribers, and there can be many more things like description of the channel, which category the channel belongs, region, and many more things, the date of creation. So you got the idea. So this is roughly database design. Now let's just see some of the API designs. So one of the APIs that you want is upload video. So only if somebody is signed into YouTube, then only upload is allowed. You can try it. If you are not signed in, it will first ask you to get signed in. So you need to pass the access token for authentication associated with the user ID, and then also the video file. Then you should be able to update video metadata. Again, you need to be signed in for all of these tasks. So you are updating the metadata of a certain video, so you need to provide the video ID. Video ID is not generated before upload, we will see that. But once a video is there live on the YouTube, there is a video ID associated with it. Then title, the new title, description, or you want to add some new tags. URL you cannot change once a video is uploaded. Then you can upload a custom thumbnail. So for that you need to tell which video you want to upload the thumbnail and the thumbnail itself. Then for searching the video, this token is not required, but it can be passed so that YouTube has a data of who queried this, so that if you are signed in, it will be used for recommending you videos in the future. Like if you signed in the YouTube homepage, it will show a bunch of recommended videos on the homepage based on search query you made in the past. Then the search query itself. Then you should be able to play the video, stream the video. So video ID and resolution that you want to play. You can also have a few more parameters like playback speed, or maybe subtitle turned on, or a few more things. You should be able to like or dislike a video. So for that also you need to be signed in, and the video ID and like, this can be 0 or 1, or true or false. So true means like, false means dislike. You should be able to post a comment in a particular video. So you need the video ID and comment text. Now let's see the design of high level design of YouTube. So there is a client here. So let's say the client wants to upload a video or search a video. So the request will go to load balancer, and it will redirect to one of the app server, and there, depending on the request, let's say the request was for video upload, so it will go to video upload service, and the video upload service will upload the video and keep the uploaded video in a upload storage. So this is the upload storage, that is video is uploaded but not processed. So this is required here because if let's say you combine upload and processing of the video into one, then if there is a disconnection, then user need to restart the whole process. So user can upload multiple videos, and it will be added in the queue, and it will be stored there, and from the processing queue the video will be passed to this transcoder, So this will encode and then transcode the video into different resolutions for adaptive bit streaming. So the idea is that let's say it first processes the transcode into 1080p, and it uses certain small blocks so that this block plays. So let's say it also creates 720p segments, then 480p. So these are in a small chunk, so that let's say in this playing of the first part of the video, there was some lag or slow speed was detected. Then once this part is played completely, it can automatically switch to low resolution 720p. So it stores all of these formats. So it not just stores the highest resolution, but it stores low resolutions as well. So it processes them, encodes them into different resolution videos, and stores the video data into blob storage or object storage, for example Amazon S3. And it also stores the video metadata associated with each video and user data into separate databases. And these blob storage is also passed to CDN in case there was a query for this video. So there can be a different algorithm altogether which videos are moved to CDN. So one of the popular ways would be that let's say user queries for certain video and request playback of certain video, and that is not in the CDN. So it will go and query the blob storage and fetch the video from there, and it will also store that in the CDN, so that next time the user searches for that, it will be directly returned from the CDN without any delay. So this way CDN will only store the most popular videos that is most frequently searched, and if some video is not searched for a long time, it can be removed from the CDN. So it's acting like a cache here. Now let's see why CDN is required here. Is it really critical in this case? CDN is very important, in fact, for an application like YouTube. So it not only takes some load off the backend, but also improves user experience in faster streaming. So as I said earlier, you can store maybe let's say top 20% most popular or hot videos in the CDN, and it will be also stored in multiple points worldwide. So that's why CDN is important here. Also a load balancer would be required, as it distributes traffic equally to different application servers. If let's say any server is not functioning properly, then this load balancer should be able to detect that and then reroute it to one of the servers that is working correctly, and it will be able to distribute the load evenly. Also it helps to scale, so that when in future the number of users is increasing, this will help in scaling the system by adding more application servers if required. And in some of the more complex systems, large scale applications having multiple data centers, the web server has to detect the IP address of the incoming request and route it to the nearest data center. So that's why this web server is very useful here. So that is the high level design. Now maybe your interviewer wants to discuss around partitioning of these video metadata and user data. So you can partition these based on certain criteria. So one of the criteria would be like based on the user ID, other could be based on video ID, or it can be, the partition can be maybe based on regions. So it's an open-ended discussion, so you can think about certain solutions how you like to partition video and user data. So I hope you were able to understand the high level design of a system like YouTube, where upload and stream service was required. So good luck and all the best for your design interviews.